integration of ln x over x dx. So there are two ways of integrating this integration of ln x over x dx. So the first method, just going to draw a line, and for the first method I'm going to use integration by part, which means that, and this can be written as integration of ln x times 1 over x dx. So using integration by part, I need to remember light. So logarithm is first. So this one is telling us which one to use as u. This is logarithm. This is inverse trigonometry. This is algebraic trigonometry and exponential. And for the logarithm here, I'm going to say u. I'm going to let u equal to ln x. And therefore, if this is u, this will be dv. And dv will be equal to 1 over x dx. So what we're going to do is find, because we're going to replace dx. So I'm going to do du will be equal to 1 over x. This is du dx. And with this one, I'm going to integrate that. So integral of dv equal to integral of 1 over x dx. And this will give v equal to ln x. And I'm going to write the integration by part, which is the integral of u dv equal to u v minus integral of v du. So I'm going to populate this now. So this will be integral of ln x over x dx equal to u is ln x and v is ln x minus integral of, well, u v du. So we're going to have du is 1 over x. Du dx is 1 over x. Therefore, du is 1 over x. So we're going to have ln x, which is v, and times 1 over x, which is over x dx. So we get the same thing back. Well, in this situation, it's best to add in order to get rid of these. So I'm going to move these to the other side. I'm going to take the minus integral of ln x over x dx to the other side. So that would be 2 integral of ln x over x dx, that equal to ln x all squared. And so what I can then do is divide both sides by 2. Therefore, the integral of ln x over x dx will be equal to 1 over 2 ln x all squared plus c. And that's the final answer for that integration. You could do the same integration by substitution. If we're to use substitution for the same integration, we can say that this is using integration by part. So for substitution, the integral of ln x over x dx, I can then say, well, let u equal to ln x. Therefore, the u dx is 1 over x. And I can make the x the subject. Therefore, the x will be du over 1 over x. 1 over x, well, let's do 1 over x, because I'm dividing both sides. I'm swapping that. So which would then become x du, because 1 over x is x. So what I need to do now is substitute the x with this. So let's go back to our integration. So with the integration, integral of ln x over x dx will be equal to, well, we know ln x is u, so that will be integral of u, and x du is dx, so that would be x times x du over x, that x. And the x cancels out, so we get the integral of u du. Using the integration formula, when you integrate, or if you're integrating x to the power of n, the integral of that, the x would be x to the power of n plus 1 over n plus 1 plus c. Well, this time is u. So u is x and n is 1. So there's a 1 there. So if we integrate that, we will get u 1 plus 1 over 1 plus 1 plus c. And that will be equal to u squared over 2 plus c. So that integration, if I replace u is ln x, and the integral of ln x over x, the x will be equal to that u, which is ln x all squared over 2 plus c. So that's the final answer, because the over 2 is a half. So this method A is substitution, and the method A is integration by parts. So that is integration by parts. Whichever one you prefer, whether integration by part or by substitution, you get the same answer.